వస్తుందా లేదా మరి చూడు అంట అందులో ఒక్కోసారి అట్లా రికార్డ్ కాదు. చేయొచ్చా? కనిపిస్తుందా?
చేసుకోవాలి.
స్టార్ట్ చేయమంటాడా? కొద్దిగా ఒకసారి చూడు మన వస్తుందా లేదా. వస్తుందట్నా? గుడ్ మార్నింగ్ ఎవ్రీవన్. టుడే కెన్ యూ ఆల్ సీ మీ? Okay, this is not Google Meet. Okay, so good morning everyone. Today the topic would be nerve injury. Okay, now, so as you all know, the nerve fiber has got an axon with its Schwann cells, and it is covered by a connective tissue layer that is called endoneurium. Axon with its Schwann cell and the connective tissue layer is called endoneurium. So what does this endoneurium contain? Endoneurium contains collagen, fibroblasts, Schwann cells, macrophages and endothelial cells. So all these nerve fibers are arranged in bundles. As you can see, they are arranged in bundles, and that bundles are covered again by a thicker connective tissue layer that is called bundles or fascicles are one and the same. So single one is the nerve fiber that is covered by endoneurium, and all these nerve fibers are arranged together in bundles or fascicles that is covered by a connective tissue layer called perineurium. And all this lot of bundles are put in a nerve, and all these bundles are covered by even a denser connective tissue layer that is called epineurium. So here you should know three words covering of a single neuron is the endoneurium, and the covering of the bundles or the fascicles is the perineurium, and lot of bundles are arranged together in a nerve, and that is called the epineurium. And if you say about the muscle, it is called as endomysium, perimysium and epimysium. So because it's a nerve, we call it as endoneurium, perineurium and epineurium. So look, even in this nerve, you can see the blood vessels inside the nerve. So introduction. When can a nerve get injured? Nerve fiber can get injured in several ways. So lot of changes will occur in the nerve fiber and the nerve cell body. When the nerve is injured, changes occur in the nerve fiber and the nerve cell body. All these changes together are called degenerative changes. These changes are called degenerative changes. What are the causes of injury? Injury to nerve fiber occurs due to the following causes. One is when you are sitting for a long time, there is compression of the nerve. So there will be interference of the blood supply to the nerve. So hypoxia to the nerve. That is a very common thing. That is the obstruction of blood flow. That is a common thing. Then otherwise, the nerve, when you inject toxic substances or poisonous substances into the nerve, then that is also a cause for injury. Then in accidents, the nerve fiber gets crushed. Automobile accidents, crushing of nerve fiber. Then through and through cut of the nerve fiber is called transection of the nerve fiber. So these are, in this ways, injury can be caused to the nerve fiber. So Sunderland has classified the injury to nerve fibers into 5 categories depending upon the order of severity. Sunderland is a person, he has classified depending upon the severity. So if this injury is not much severe, there will be recovery of the functions. If the injury is transient, recovery of the functions will be quick, probably in days or weeks. So that is first degree injury. Depending upon if the injury is very severe, then the nerve cannot degenerate. The nerve degenerates and it cannot regenerate. So depending upon the severity of the injury, if it is a transient loss of functions, it can recover. Then if the injury is very severe, this will lead to degeneration of the nerve. So Sunderland has described The degree, or depending upon the degree of injury, is said first degree injury, second degree injury, third degree injury, fourth degree injury, and fifth degree injury. So there is one more classification also, that is called Seddon classification. Both together I will tell you. So first degree injury, that Seddon has called it as neuropraxia, is one more, is another person, Seddon. If you can see the last line, Sceddon. So he said, instead of using the word first degree injury, he has used the term neuropraxia. So this is the most common type of injury. It is caused by applying pressure over a nerve for a short period of, limited period of time. So there will be occlusion of blood flow leading to hypoxia. So in this injury, axon is not destroyed, but mild demyelination might occur. Axon is not destroyed, so only demyelination of the nerve, only the myelination, there will be little bit of destruction of the myelination. So axon loses the function temporarily. Because of this demyelination, axon will lose the function temporarily for a short time, which is called conduction block. The function returns within a few hours to few weeks. Because here the axon is not damaged, only the myelination is damaged, there will be only temporary loss of function, and that function will recover quickly. This is called conduction block. So Seddon has said this word as called neuropraxia. So the good example I would give you for this is Saturday night palsy. A person who is drunk on a Saturday night will keep his hand under his head and sleep. So there will be reversible paralysis of the radial nerve. So again, the radial nerve will get recovered. So this is first degree. Coming to the second degree injury, so that person has named it, Seddon has named it as axon not-mesis. Axonotmesis. Okay. So it is due to the prolonged severe pressure. There, that was for a limited time, that pressure. And that's why the nerve could recover. Here in this, it is due to the prolonged severe pressure which causes Wallerian degeneration. It is due to the prolonged severe pressure. So here you should use the word Wallerian degeneration. Prolonged severe pressure which causes Wallerian degeneration. We'll come to it in detail in the coming slides. Okay, here the endoneurium is intact, but the axon is damaged here. The endoneurium is intact. The covering of the connective tissue covering this nerve fiber is intact. The endoneurium is intact. Repair and restoration of function takes about 18 months. So this is called second degree of injury. Seddon has named it as axonotmesis. So here in this, axon is damaged. Due to the severe pressure on the nerve fiber, axon is damaged. Third degree of injury. Third, fourth and fifth, that person Seddon has named it as neurotmesis. Third degree injury. That is axonotmesis, because axon has damaged. Here he has named it as neurotmesis. Here the endoneurium is interrupted. Epineurium and perineurium are intact. In third degree, endoneurium is interrupted. Epineurium and perineurium are intact. After degeneration, the recovery is slow or poor or incomplete. The recovery is very slow. It will take very long, and if it has recovered also, it's very poor or incomplete. Third, fourth and fifth degrees of injury are called neurotmesis according to Seddon, because here endoneurium is damaged. Fourth degree, this type of injury is more severe. Epineurium and perineurium are also interrupted. Fasciculi of nerve fibers are disturbed and disorganized. The fasciculi are destroyed. Regeneration is poor or incomplete. Regeneration in this is poor or incomplete. Fifth degree injury. It involves the complete through and through cut of the nerve trunk with loss of continuity. It involves complete transaction of the nerve trunk with loss of continuity. Useful regeneration is not possible unless the cut ends are brought together and approximated quickly by surgery. So, first degree only damage to the myelination. Second degree is damage to the axon. Third degree is damage to the endoneurium. Fourth degree is damage to the perineurium and epineurium. Fifth degree is through and through cut. Now, what are the degenerative changes in the neuron? What will happen? So, here basically Wallerian degeneration for the second degree. We are talking about the second degree. Here the axon is damaged and what will happen? That is called the Wallerian degeneration. For second degree it applies. When a peripheral nerve fiber is injured, the degenerative changes occur in the nerve cell body and the nerve fiber of same neuron and the adjoining neuron. So, whenever a nerve fiber is injured, so these degenerative changes are occurring in the nerve cell body and the nerve fiber of the same neuron, or at times the adjoining neuron also will get damaged depending upon the severity. Accordingly, degenerative changes are classified into three types: Wallerian degeneration, retrograde degeneration, transneuronal degeneration. Wallerian degeneration means it is occurring in the distal stump only. Wallerian degeneration. So, it is occurring in the distal stump. Retrograde degeneration means it is occurring proximal to the injury. Wallerian degeneration is distal to the injury. Retrograde is proximal to the injury. And transneuronal degeneration is, if one neuron is affected, it will affect the other neuron also. That is transneuronal degeneration. So, what degenerative changes can occur in the nerve cell body and the nerve fiber of the same nerve fiber or the adjoining one. So, Wallerian degeneration is also called orthograde degeneration. It is occurring distal to the injury. So, it is also called orthograde degeneration. Some books have also said antegrade degeneration. Antegrade. So, it is occurring distally. So, Wallerian degeneration is the pathological change that occurs in the distal cut end of nerve fiber. Whenever a short question of Wallerian degeneration is asked, you should write the changes occurring in the distal end of the nerve fiber. Distal end. Okay, only those changes. It was named after the discoverer Augustus Waller. He is a neurophysiologist. These changes, he was the first one to see these changes. So, this is named after the discoverer Waller. That is why it's called Wallerian degeneration. So, these changes are occurring in the distal cut end of the nerve fiber. It's also called orthograde degeneration. It is also called orthograde degeneration, and some books have said antegrade degeneration. So, it is occurring distal to the injury. That's why it's called orthograde or antegrade. If it is occurring proximally to the injury, we call it as retrograde degeneration. So, Wallerian degeneration starts within 24 hours of injury. So, this degeneration will start within 24 hours of injury. Changes occur throughout the length of the distal part of the nerve fiber simultaneously. So, degenerative changes and regenerative changes are also occurring simultaneously. We'll come to it later. So, changes are occurring throughout the length of the distal part of the nerve fiber. What are the changes in the nerve? What will happen? So, once the axon, here we are talking Wallerian degeneration is occurring usually the second degree of injury. So, what will happen when the axis, when there is injury to the nerve, the axis cylinder swells and breaks up into small pieces. So, it is first and foremost, the synaptic transmission is lost. Synaptic transmission is lost. Okay, so the axis cylinder swells and breaks up into small pieces. After a few days, the broken pieces appear as debris in the space occupied by the axis cylinder. So first, the axis cylinder, it swells up, and both the cut proximal end and the distal end, they swell and they get sealed up. They get sealed up. So after a few days, the broken pieces appear as debris in the earlier where the axon was there, that is all broken into small pieces. Now we see the debris in that place of axis cylinder. So myelin sheath is slowly disintegrated into fat droplets. The myelin sheath axon has got a myelin sheath. This myelination in the peripheral nervous system is due to Schwann cells, whereas myelination in the brain and the spinal cord is due to oligodendroglia. Here you should remember that myelination in the peripheral nervous system is due to Schwann cells, whereas in the brain it is due to oligodendroglia. So myelin sheath is slowly disintegrated and it is becoming to fat droplets. These changes in the myelin sheath occur from 8th to 35th day. So because of these days, I could not remember. That is why I have written on the slide. So these changes in the myelin sheath, where it is getting disintegrated and becoming into fat droplets, will start from the 8th day and complete by the 35th day. Neurilemmal sheath is unaffected. So what is neurilemma? Neurilemmal sheath is covering the myelin sheath. Over the myelin sheath, there is the neurilemmal sheath. So neurilemmal sheath is made up of Schwann cells. So this neurilemmal sheath will have the cytoplasm and the nucleus. From this neurilemmal sheath covers the myelin sheath. After this neurilemmal sheath, you see the endoneurium. So don't get confused between the endoneurium and the neurilemmal sheath. Neurilemmal sheath is covering of the myelin sheath. It has got a nucleus and the cytoplasm. Neurilemmal sheath is unaffected and it remains as a hollow tube. So this neurilemmal sheath is made up of Schwann cells. That is why the Schwann cells multiply rapidly. The Schwann cells multiply rapidly. So now that axis cylinder is swollen up and all it is broken down into small segments, and the myelin sheath has become into fat droplets. So all this debris is there which was previously occupied by the axon cylinder. So now what will happen? Neurilemmal sheath is unaffected. So neurilemmal sheath is made up of Schwann cells. Now the Schwann cells will multiply rapidly. So Schwann cells will multiply rapidly. Macrophages, I said endoneurium has got macrophages also. Macrophages invade from outside and remove the debris of axis cylinder and fat droplets of the disintegrated myelin sheath. So now macrophages come and phagocytosis of this debris material of the axis cylinder and myelin sheath. It will macrophages invade and debris the axis cylinder and fat droplets of the myelin sheath. All these changes take place for about 2 months from the day of injury. All these changes will take place about 2 months from the day of injury. After the injury, 2 months, this macrophages will invade and clear the debris. Now the tube which was axonal tube which was there earlier is all cleared. The debris is all cleared. The cleared tube, now the Schwann cells will multiply rapidly and occupy this tube which is cleared now. Now look at this diagram. So here is the nerve damage. If you can see site of nerve damage, it is there with an arrow. Now look at the axis cylinder. It is fragmented. It is broken down into fragmented pieces of axon are there. Small pieces are there. And look at the myelin sheath. So myelin sheath has disintegrated and you can see as droplets of fat droplets or lipid droplets. Okay. Look at the endoneurium. This is the endoneurium. So above this where the Schwann cells are there, covering that will be your neurolemma. That is not shown in the diagram, but below the endoneurium and above this myelin sheath, Schwann cells will be the neurolemma. Now, this part which has been broken down into small pieces, this macrophages come and clear all this debris, and this part has become very clear. Now, the Schwann cells from the distal end of the injury and from the peripheral side of the injury, they multiply rapidly. They can multiply only if the neurolemma is intact. That you should remember. They can multiply rapidly only if neurolemma is intact, because Schwann cell, neurolemma is made up of Schwann cells. So it has to be intact, then only they can multiply. The Schwann cells multiply rapidly. So retrograde degeneration. Now I said orthograde degeneration. Now retrograde degeneration means these changes are occurring in the nerve cell body and axon proximal to the cut end. Retrograde changes. Retrograde degeneration is the pathological changes which occur in the nerve cell body and axon proximal to the cut end. Changes in the axon proximal to cut end are just the similar what has happened to the distal end, but it can these changes will take place only up to the one node of Ranvier. In the axon, changes occur only up to the first node of Ranvier from the site of injury. These changes are very quantitatively very less. They occur only up to the first node of Ranvier from the site of injury. Degenerative changes that occur in proximal cut end of axon are similar to those changes occurring in the distal cut end of the nerve fiber. Changes are just the same. Whatever is happening, here also the debris will be there. The debris is cleared by the macrophages and the Schwann cells will multiply. Changes are just the same, but it is proximal and it is occurring only up to the first node of Ranvier from the site of injury. These are the retrograde changes. Now we have seen what is happening in the axon. Axon. Now let us see what are the changes that are occurring in the nerve cell body. Changes in the nerve cell body. Changes in the nerve cell body commence within 48 hours after the section of nerve. The changes are, first the Nissl granules disintegrate into fragments by chromatolysis. Disintegration of Nissl granules is called chromatolysis. So Nissl granules get disintegrated. We are seeing the changes in the nerve cell body. So Golgi apparatus is disintegrated, and the number of this Golgi apparatus number has decreased drastically. Golgi apparatus is disintegrated. Nerve cell body swells due to accumulation of fluid and becomes round. Nerve cell body also because of the fluid. Cells are all nothing but a fluid. So accumulation of fluid and they become round. Neurofibrils disappear, followed by displacement of the nucleus towards the periphery. Neurofibrils disappear and the nucleus is moved towards the periphery. Sometimes the nucleus is extruded out of the cell. Sometimes the nucleus comes out of the cell. If the nucleus has come out of the cell, death of the neuron occurs. Death of the neuron occurs and regeneration of the injured nerve is not possible. Okay, now the nucleus should be there, then only this degenerative and regenerative changes can occur. Once the nucleus is pushed out of that neuron, death of the neuron will occur. So these are the retrograde changes. What I told you is Wallerian degeneration, only anterograde changes are called Wallerian degeneration. Anterograde or orthograde is one and the same. So look at this Wallerian degeneration. What is happening at the distal end of the cut? So what are the happening? The proximal end are called retrograde changes. Look how the nucleus is come towards the periphery and Nissl granules have all disintegrated. Okay, so degeneration of myelin is occurring, degeneration of axon. So I told you earlier. Now, third one, I told you Wallerian degeneration, anterograde degeneration, retrograde degeneration. Third one I told you is transneuronal degeneration. Now coming to the transneuronal degeneration, if an afferent nerve fiber is cut, the degenerative changes occur in the neuron with which the afferent nerve fiber synapses. Supposing one nerve fiber is cut, if it is making the synapse with the other nerve fiber, that also get degenerated. It is called transneuronal degeneration. Transneuronal. Example for this: degeneration of cells in the dorsal horn of the spinal cord occurs when posterior nerve root is cut. So this, if you can recollect the spinal nerves, how they are placed, if you can, so if first order neuron comes from the dorsal root ganglion. So if the posterior nerve root is cut, the cells of the dorsal horn of spinal cord gets degenerated. This is transneuronal degeneration. Other example is degeneration of cells in ventral horn of the spinal cord occurs when there is tumor in the cerebral cortex. So the first example is for sensory. Sensory, they are going afferent neurons. So they are going to the brain. So the second example is it is coming from the brain towards the ventral horn. So degeneration of cells in ventral horn of the spinal cord occurs when there is tumor in the cerebral cortex. So this is above one is sensory and below is motor. And other example also I can see when say is when the optic nerve is cut. So you will see the degeneration of the lateral geniculate body. So it is making connections with that. So when this is degenerated, the other part also gets degenerated. This is called transneuronal degeneration. Coming to the next slide. Now degeneration changes we have seen. Now coming to regeneration of nerve fiber. Degeneration and regeneration are occurring simultaneously. Degeneration is destructive process. Regeneration is constructive. So regeneration of nerve fiber. The term regeneration refers to regrowth of lost or destroyed part of the tissue. Whatever has been damaged, when that grows back, it is called regeneration. The injured and degenerated nerve fiber can regenerate. Degenerated nerve fiber can regenerate. Not all will regenerate. So it has to obey some criteria. We'll come to that. So it starts as early as 4th day after injury, but becomes more effective only after 30 days and is completed in about 80 days. So because of these days, I can't remember. That's why I've written everything clearly. So this changes. It starts as early as 4th day after injury, but becomes more effective only after 30 days and is completed in about 80 days. Regeneration. So all this while we were seeing about the degeneration. Now we are coming to regeneration of the nerve fiber. What is the criteria for regeneration? So gap between the cut ends of the nerve should not exceed 3 millimeters. That is the topmost criteria. If the gap is more than 3 millimeters, scar tissue will form. So regeneration can occur only if the gap between both the cut ends is less than 3 millimeters. Neurilemma should be present. Only if neurilemma is intact, there will be multiplication of the Schwann cells. If the neurilemma is gone, nothing can be done. Neurilemma should be present. This is the criteria for regeneration. When the nerve can get regenerated, neurilemma should be present. Nucleus must be intact. If it is extruded from the nerve cell body, the nerve is atrophied and the regeneration does not occur. Nucleus must be intact, and if the nucleus is coming out of this nerve cell body, regeneration can never occur. Two cut ends should remain in the same line. Cut ends, if one end is somewhere and the other end is somewhere, they make connection with the wrong nerve endings. So what is it? Now supposing, what example can I give you? Supposing the nerve endings, nerve fibers which carry temperature sensation can make connection with the touch receptors. can make connection with the touch receptors. So when the touch receptors are touched, instead of the touch, these receptors will carry the temperature sensation. It is misinterpreted. Touch receptors, when you touch the touch receptors, instead of giving a touch sensation, what temperature sensation is carried. It is misinterpreted as temperature sensation. So if the cut end should remain the same line, otherwise it make connections with the wrong nerve endings. Okay. Then regeneration does not occur if any one end is moved away. Same thing. They should be in the same line. If one is moved away, regeneration cannot occur, or it will make connections with the wrong nerve endings. So instead of one sensation, we'll feel the other sensation to whichever it is making connection with. What are the stages of regeneration? So when will the regeneration occur? I said it should be within 3 millimeters. What will happen? First, this regenerative changes are occurring only at the proximal end. Only at the proximal end they are occurring. First, some pseudopodia like extensions grow from the proximal cut end of the nerve. These extensions are called fibrils or regenerative sprouts or axon sprouts. These extensions, wherever the axon is there, from there lot of multiple fine nerve fibers will come out, and these are called as regenerative sprouts. Fibrils move towards the distal cut end of the nerve fiber. So wherever the tube is intact, the cut end of the tube, original cut end of the tube, these fibrils should come and make contact with the distal cut end of the nerve fiber. Some of these fibrils enter the neurolemmal tube of the distal end and form axis cylinder. So the axon will sprout and say it might give about 100 fine branches. So in this 100 fine branches, only two or three might enter this neurolemmal tube, but only one will be successful. When one will be successful and it make a thorough alignment with the neurolemmal tube, the other fibrils will disintegrate. Some of these fibrils enter the neurolemmal tube of the distal end and form axis cylinder. Schwann cells line up in the neurolemmal tube and actually guide the fibrils into the tube. So, Schwann cells are responsible in guiding these fibrils to enter into the correct tube. Schwann cells are responsible for showing the path. Schwann cells also synthesize some nerve growth factors, some neurotrophins, which attract the fibrils from proximal segment. So, lot of sprouts, axonal sprouts will be there. So, 2 or 3 sprouts may enter the neurolemmal tube, but only one sprout will enter successfully, and that is going to become an axon. What will happen? Axis cylinder is fully established inside the neurolemmal tube. So only one sprout is coming and making contact. These processes are completed in about 3 months after injury. Okay, this process takes about 3 months after injury. Myelin sheath is formed by Schwann cells slowly. Myelination is completed in 1 year. So this is the new nerve fiber which has entered the neurolemmal tube. So this new nerve fiber does not have myelin, and the new nerve fiber, how much ever it grows in size, it will be only maximum up to 80% of the original nerve fiber. It can't grow beyond that. Okay, and myelination, slowly the Schwann cells will come around it and myelination will occur. Is completed in 1 year. Diameter of the nerve fiber gradually increases. How much ever the diameter increases, it will not be 80% of the, it will not be more than 80% of the original nerve fiber. In the nerve cell body, what is happening again in the nerve cell body? The Nissl granules appear. followed by Golgi apparatus. Slowly, one by one is coming. Nasal granules is coming. Golgi apparatus is coming. Cell loses that extra. Cell initially was very swollen up. It will lose that excess fluid, and nucleus slowly from the periphery it will come into the central portion. Though anatomical regeneration occurs in the nerve, functional recovery occurs after a very long period. Anatomically, regeneration is occurring. It looks perfect like a nerve, but the function of that will come back after a very long period. So what is the how is the process of regeneration occurring? Process of regeneration of neuron is helped by growth stimulating substances which are secreted from Schwann cell. Growth stimulating substances are present in the Schwann cell. That is why the Schwann cell is directing in the correct path. So neurotrophins are there. Neurotrophins 3, 4, 5, some brain derived growth factors. All these growth factors, these are nothing but the proteins. These are guiding them. And some special cell adhesion molecules. All this are happening. So these are responsible for the regeneration. Also, perineurium secretes inhibitory substances to guide the sprouting axons in the correct path. Perineurium also secretes some protein substances so that it can guide the sprouting axon in the correct path. When that alignment is very crucial, if this alignment is correct only, then the nerve will regain its function. Nerve fiber will regain its function. See, this is the diagram. See, first this is a proper nerve fiber. Here it is cut. So axonal sprouting, can you see axonal sprouting occurs only at the proximal end. So only one is becoming successful and Schwann cells are responsible for it to take it in the correct path. Slowly it is coming and making contact. So axon is regenerating. Axon is regenerating and the remaining sprouts are degenerating. Only one will be successful and the remaining sprouts are degenerating. That is coming and making contact. This is Schwann cell. So chromatolysis no longer. See, look at this. Nucleus is coming to the periphery. It is pushed out. There are no nasal granules. Now slowly nasal granules, everything is coming back. Chromatolysis no longer present. And slowly it is getting into the target. Is re-innervated. Target is re-innervated. Okay, but it will take very long. And for this, you should remember the neural lemma should be intact. Then only Schwann cells multiply and fill this gap. If this gap is not filled, the neuron will get damaged. Why doesn't the regeneration will not occur in the CNS? Whereas regeneration is occurring in the peripheral nervous system, but regeneration can never occur in CNS because unlike peripheral nervous system, axonal regeneration cannot occur in central nervous system. Why? Because their oligodendroglia, they cannot form a path along which sprouts can grow. Oligodendroglia, they cannot form a path. Here Schwann cells are forming a path so that one sprout is getting successful. Here oligodendroglia cannot form a path along which the sprouts can grow. Why? Because whereas one Schwann cell is responsible for myelination of a single axon, whereas this oligodendroglia, the myelination, it is forming for the lot of central axons. That is not responsible for only one axon, but lot of central axons. Myelination, oligodendroglia is providing myelination for lot of axons, unlike the peripheral nervous system where the Schwann cell is having the myelination for single axon. Alternatively, the central nervous system chemical signals might be different and peripheral nervous system signals might be different. So, these chemical signals might be different. So, that is not encouraging for the regeneration of the axon. So, formation and also the astrocytes. The brain, CNS has got astrocytes also. This will form the glial scars very quickly. Astrocytes will form the glial scars very quickly. Once the scars are formed, it is impossible for the regeneration to happen. And also some secretion of inhibitory substances. Oligodendrocytes secrete some inhibitory substances which will prevent the axonal regeneration. And one more thing here I would like to tell you is, when the regeneration is occurring in the peripheral nervous system, if the gap is more than 3 millimeters, this multiple outgrowths will intermesh and form a tumor that is called neuroma. Once the neuroma is formed, it will not, regeneration can never happen once the neuroma is formed. And one more thing, if those nerve fibers are particularly sensory nerve fibers are involved in this, when you touch that area, you will feel the pain. And also when the injury is very close to the cell body, regeneration chances are very minimal or absolutely no chance of regeneration, because there will be neuron will get damaged. It should be far away from the cell body, then only axonal regeneration changes can occur. And if at all, if the through and through cut is there, so plastic surgeons will try to bridge the gap and bring the two ends of this neurolemmal tube as close as possible so that proper alignment can occur. So if the gap between the two ends is what within 3 millimeters, then regeneration chances are there. So plastic surgeons will try to get the gap to up to 3 millimeters. If the gap is more, nothing can happen, only a neuroma will take place. Okay. So here what did we see today? We have seen what is nerve injury, different degrees of nerve injury. I've told you about the Sedan classification, and also what classification was that? Sunderland classification. So I told you about the Sunderland classification. I told you about the Sedan classification and degrees of injury. When demyelination occurs, nothing can be done. It will come back, the functions in first degree. Second degree, we have seen this Wallerian degeneration and regenerative changes. Third degree, I told you what will happen. Third, fourth and fifth degrees, and different names by Sedan also I told you. Then what are the changes, degenerative changes? 3 changes. Wallerian degeneration is occurring only at the distal side. Peripheral side to the injury is retrograde, and when one neuron is damaged, the second, where it is synapsing, that neuron also will get damaged. That is transneuronal degeneration. Okay. Then I told you what about the Wallerian degeneration, from when it starts, what are the changes. So here basically you should write axis cylinder is broken down into fragments, then myelin sheath is disintegrated and into droplets, and all this is macrophages come and clear this debris. When the tube is very clear, Schwann cells will multiply, and they'll try to, Schwann cells multiplication will occur from both the sides, but from the periphery side it is comparatively very less compared to the distal side. Okay. So I've told you how Schwann cells, how it is broken down, and how the changes are occurring in the retrograde degeneration. What are the changes occurring in the nerve cell body? What is anterograde is Wallerian degeneration. If Wallerian degeneration is asked, you should only write about the anterograde changes. Don't write about the retrograde changes. So transneuronal degeneration I told you with the examples, and regeneration I told you. Degeneration is followed by regeneration. criteria. What should be the criteria for regeneration? Stages of regeneration. So multiple axonal sprouts are there, but only one will become successful and enter the neurilemmal tube. That part is very critical and crucial. If the proper alignment is there, then only the nerve will get repaired and start functioning. So I told you what will happen. Process of regeneration. This is the diagram. And why the regeneration is not possible in CNS. CNS also axons will give away the sprouts, but that is not possible because oligodendroglia there is covering lot of central axons. Okay, and could be because different chemical signals in the brain and peripheral nervous system, or and this astrocytes, they form glial scars very quickly in the brain. Glial astrocytes are the supportive tissue. They give nourishment to this oligodendrocyte. Okay, hope it's clear and you understood it.